Okay. So scientific notation is used with really big numbers or really small numbers. So that way we don't have so many zeros. Because whenever you read something like, I don't know, say in a paper, and it has a ton of zeros, it's kind of hard to decipher what number that is. It's just a little bit distracting. So it's easier to write really big numbers like for those astrophysicists, those things where they're studying space, stuff like that. Okay, they need to have a different notation in order to write their numbers a little bit more
Do we need to know that?
simply. Yes. Okay, so let's say, I'm not going to write like a ginormous number, but let's just say 63 million. Okay?
Oh, that's not big.
That's
It's
a
not
ginormous.
ginormous, but
That's
let's go
just
ahead and
small.
No, that's a big number. Someone weighed
You
that
guys-
much.
let's talk about how we're going to write this in scientific notation.
Oh, is that that one we have to like break it down or whatever?
Jack, Andre, and Riley, this is your last warning. Thank you. Okay. So, I'm going to put a decimal right here. Standard form, or proper form, okay, is to have one non-zero number to the left of your decimal. So you want one non-zero number. So that means it can't be zero, right? To the left of the decimal. Okay, so far I have 6.3, and then I'm going to multiply it by 10. Okay, the number of times that it would take in order to multiply 6.3 times 10 in order to get this number. How many times would we have to multiply this by 10 in order to get 63 million? Okay, well there's an easy way to figure that out.
100,000 times.
Okay, on 63 million our decimal's right there, right? It's at the very end of that number. Okay, so we're going to see how many places we have to move that decimal, okay, in order to get it where we want it. We have to move it 7 times,
Oh,
right?
I thought it was like.
So it's not the number of zeros. One misconception is it's the number of zeros that's on your number. It's not. It's how many places you have to move that decimal in order to get it where you want it to go.
But
Okay?
it still
So-
would be the numbers.
Oh, I get it.
What this means is if we multiply 6.3 times 10 7 times, we get 63 million.
That's sick.
Okay? Because we multiply it by 10 one time and we get 63, right? Multiply it by 10 two times, we get 630. You guys got it? Does that make sense?
6,000? No.
Okay, Naomi.
How do you know where to put the decimal?
You want one number that's not 0 to the left of it.
What if it's just like...
Jack?
So is it always 10? We are multiplying it with?
Yes.
Okay.
Scientific notation is always factors of 10. Yes.
So is
Okay.
6.3 times 10 to the 7th the answer?
Yes. This is the scientific notation for that number.
That was easy.
Oh, okay.
Okay. Now, if you have a really big number, it makes sense that you would have to multiply this small decimal number by 10, right? So your exponent is positive. But what if we have a really small number? So
Or
let's
it's
start with a
negative.
really small number.
That's how fast the
Okay.
line goes.
That number is way less than 1, right? Everybody see that? Okay. Hi. So now, so now where do I want my decimal?
Oh,
between the 8 and the
2. Wait, between the 8 and the 2.
Yes, because that's going to give me one non-zero number to the left of it. Does that make sense?
To be negative.
Okay, so I'm going to end up 8.2. I'm going to figure out how many times I had to move my decimal to get it there. 3, 4, 5, 6.
-6.
Okay, so it's going to be 8 times 2 times 10 to the negative 6. This exponent is negative.
So you had to put the
Because-
1 under it.
What it means, no, you're going to leave it with a negative exponent. Leave scientific notations with negative exponents. Okay? So, what this means is that in order to get this small number from 8.2, we would have to divide by 10 6 times. That make sense? A negative exponent means that we're dividing by 10 that many times. So, a good way just to remember it is if you have a really big number, your exponent on your scientific notation is positive. Okay? Small number less than 1, your exponent on your scientific notation is negative. Natalie?
Will it always be a 10 right there, like times
Yes.
10?
Always times 10. Okay, that's what scientific notation is. And the reason why it is 10 is because you have a ton of zeros in your number. What do those zeros mean? They mean multiples of 10, right?
Yep.
So they're like place values of 10. So that's why this is 10. Cool? It's not 8, right? Because we don't work in groups of 8. We work by tens.
That would be hard to work by groups of 8. I know it would.
But what
That
if
would
we
be hard.
learned like that?
Then
Then
we'd be geniuses.
Yeah. No, you just.
Okay, what if we go backwards? Let's go backwards. What if I give you a number in scientific notation? Then you
you solve
answer it. Okay?
Oh, that's
And I want it in standard notation.
We're supposed to
Let
do
me do
this.
this, please.
You solve it in a calculator.
You don't.
Okay? Now what do I need to do? I start with 3.5. Okay?